This video is a summary of several different VTOL types. Let's get started. Separate power plant for hover. In this type, different engines are used for vertical and horizontal flight. The Dassault Mirage III V is an example of this type. The Mirage III V was based on the Mirage III Delta Wing fighter but incorporated 8 small vertically mounted lift jets in the forward fuselage for vertical takeoff and landing, in addition to a main engine for forward flight. For vertical takeoff and landing, the lift jets provided upward thrust. Once airborne, the main engine would transition the aircraft to horizontal flight, and the lift jets would be shut down. The aircraft then flew like a conventional jet. Another example is the Short SC-1, which was the UK's first fixed-wing VTOL aircraft, built primarily for research. It used 4 vertically mounted Rolls-Royce RB-108 lift jets for vertical flight and a single RB-108 for forward propulsion. These aircraft were heavy, fuel-inefficient, mechanically complex, and ultimately impractical for operational military use due to the burden of extra engines and difficult transitions. Combined power plant for hover. Unlike the previous type, this aircraft type uses one or more of its engines during both hover and forward flight. The Yak-38 and Yak-141 are some of the most famous examples of this type. The Yak-38 was the Soviet Union's only operational VTOL strike fighter, designed to operate from the smaller Kiev-class aircraft carriers. Its propulsion system combined a single main turbojet with vectored thrust nozzles for forward flight and 2 smaller vertically mounted lift jets behind the cockpit for vertical takeoff and landing. During VTOL operations, all 3 engines provided lift. In horizontal flight, only the main engine was used, with the lift jets shut down. A similar principle can be seen in the Yak-141. Some more notable examples of this type are the Lockheed XV-4B Hummingbird and the Dornier Do-31. Augmented power plant. In this type, the power plants are used to drive another device to provide additional vertical thrust in hover. This class can be divided into 2 categories, Ejector and Liftfan. A famous example of the Ejector type is the Rockwell XFV-12. It employed a unique thrust-augmented wing system. In this system, the engine's exhaust was diverted through ducts and expelled downward via special vents in the wings and large canards. These vents opened up like Venetian blinds, allowing the high-speed exhaust to flow through and generate additional lift by entraining ambient air, a process intended to augment the total lifting force. The concept worked in principle, but real-world tests showed much lower lift augmentation than predicted. The XFV-12 was never able to perform an untethered vertical takeoff, leading to the project's cancellation. The second type is Liftfan, and you might have already guessed the aircraft, the F-35B. Located behind the cockpit, the Liftfan is powered by a driveshaft connected to the main engine. When VTOL or short takeoff and landing or STOVL mode is selected, a clutch engages, spinning up the lift fan. The fan draws air from above the aircraft and expels it downward, generating vertical lift at the front of the jet. At the rear of the aircraft, the main engine exhaust passes through a nozzle that can rotate 90 degrees downward. This provides vertical thrust at the rear of the aircraft, balancing the lift generated by the fan. For roll control during hover, bypass air from the engine is diverted through small nozzles, roll posts, in each wing, letting the pilot fine-tune the aircraft's orientation. Once airborne, the lift fan disengages, the nozzle returns to its rearward position, and the aircraft transitions to conventional jet flight. Other aircraft that used augmented lift are the GE Ryan XV-5A and the Vanguard Omniplane. Same propulsion system for hover and cruise. This class of aircraft uses a single propulsion system that alters the direction of thrust for hover or cruise, or alters the attitude of the aircraft itself. This type can be further categorized into several different types. Let's look at them one by one. Tail sitters. As the name suggests, this aircraft type sits on its tail for takeoff and landing, then transitions by pitching forward to fly horizontally like a conventional fixed-wing airplane. Tail sitters do not require complex mechanical systems to change the orientation of rotors or wings. Instead, the entire airframe rotates during the transition between vertical and horizontal flight modes. They can operate in confined spaces without runways, combining the operational flexibility of helicopters with the efficiency of airplanes. The transition between vertical and horizontal flight is aerodynamically complex and can be hard to control, especially during landing. Manned tailsitters historically suffered from poor pilot visibility and challenging control during vertical descent and landing. However, this type is well suited to UAVs. Hover and transition phases can be unstable in windy conditions. Some notable tailsitters include the XFY-1 Pogo, the Lockheed XFV-1, and the Ryan Vertijet. Tilt prop. In this type, the propellers rotate 90 degrees to provide lift for hover and thrust for cruise. A notable example of this is the Curtiss-Wright X-19. The aircraft was powered by two Lycoming T55L7 turboshaft engines, each producing 2,650 shaft horsepower, mounted inside the fuselage. Power was transmitted to the propellers via a complex system of drive shafts and gearboxes. Each of the 4 propeller nacelles could rotate through 90 degrees, allowing the propellers to point upward for vertical lift like a helicopter or forward for conventional flight like an airplane. Tilt duct. As the name suggests, this type uses duct propellers which tilt 90 degrees for hover and cruise. A famous example is the Bell X-22. The X-22 was equipped with 4 large, variable pitch, 3-bladed propellers, each housed within a rotating duct at the tips of its tandem wings. These ducts could rotate from 0 degrees to 95 degrees. The aircraft was powered by 4 General Electric YT-58 GE 8D turboshaft engines, each producing 1,250 shaft horsepower. Other examples of this type include the Duct 16VZ4 and the Nord 500 Cadet. Tilt wing. Tilting the entire wing, instead of just the rotor or propeller, provides the benefit of increasing aerodynamic flow over the lifting and control surfaces during transition, and minimizes the lift loss due to downwash in hover. The disadvantages are that an additional method of control such as a tail jet or rotor is required for control in hover, and ailerons change from roll control in horizontal flight to yaw control in hover. Control is especially difficult in hover during gusts due to the barn door effect of the wings in a vertical position. Examples include the Hiller X-18, VTOL 76VZ2, LTV XC-142, and Canadair CL-84. Tilt rotor. In this type, the rotors, along with the engines, are tilted. The most famous example is the V-22 Osprey. The V-22 features 2 large 3-bladed rotors mounted on nacelles at the wingtips. Each nacelle houses a Rolls-Royce AE1107C turboshaft engine and a transmission system. The nacelles can rotate from a vertical position for helicopter-like VTOL and hover to a horizontal position for airplane-like forward flight, with intermediate angles possible for short takeoff and landing. Other examples are the Bell 609 tilt rotor and the Bell XV-15. Tilt jet. Like the tilt rotor, the tilt jet rotates the entire propulsion system from the vertical position, for hover, to the horizontal, for conventional flight, but uses jet engines. Deflected slipstream. In this type, the propeller slipstream is directed 90 degrees downwards with flaps, which forms a bucket that can vector propeller thrust vertically. An example is the Ryan 92VZ3 vertiplane. It was powered by a single Lycoming T53L1 turboshaft engine located in the fuselage. The engine drove 2 large-diameter 3-bladed propellers. The aircraft featured wide-span, double-slotted flaps that could be extended downward into the propeller slipstream. When the flaps were deployed, they formed a bucket that redirected the propeller slipstream downward, generating additional vertical lift for short or near-vertical takeoff and landing. Another example is the Fairchild 224 VZ5. Vectored thrust. This class of aircraft vectors the exhaust of the jet engine to create vertical or horizontal motion. The most famous example is the McDonnell Douglas British Aerospace Harrier. The Harrier is powered by a single Rolls-Royce Pegasus turbofan engine. The engine has 2 intakes and 4 synchronized, rotatable exhaust nozzles, 2 at the forward cold end and 2 at the rear hot end of the engine. This configuration allows the pilot to direct engine thrust downward for vertical or short takeoff and landing, or rearward for conventional forward flight. Other examples include the Boeing X-32 and Yak-36. These were some ways in which VTOL airplanes have been designed in the past. If you found the video informative, please give it a like. Of course, a lot of types were not included in this video, such as helicopters, tip jets, stopped rotors, and the new eVTOLs. They could be discussed in a future video. For more videos on aircraft design, subscribe to the channel. You can watch these videos next for more on aircraft design. Thanks for watching.